Alright guys, this is the Chapter 7 Mole Ratios and Classifying Reactions video. So let's go ahead and discuss mole ratios very quickly. You have to know about balanced equations before you can do mole ratios because you have to do mole ratios once you've balanced an equation. Now a balanced equation tells you the mole ratio or the proportion of reactants and products in a chemical reaction. Now, mole ratios tell you the relative amounts of reactants and products, and mole ratios can be converted to masses. So if you have a balanced equation, you can take the mole ratios and determine how much of a substance you need to make the chemical reactions in the lab. Now, the coefficient in the chemical reaction tells you how many moles of that compound is in the reaction. So let's go ahead and we're going to practice these, do a couple of practice problems. Okay, I have three balanced equations that we had done yesterday, so let's talk about moles now. Now I've put the coefficients in red so that you can see them. Now the mole ratio for the top equation with zinc, oh you know what, let me go ahead and number these so that we can just say number 1, 2, or 3. So for number 1, the mole ratio is 2, 2, 2, 1. Now, over here with hydrogen, there is nothing there, so that means 1 is understood. Because if I have H2, that just means I have 1 of H2. So the mole ratio for chemical equation number 1 is this right here. Now, if I were to ask you a question like, how much zinc do I need to produce 1 mole of hydrogen 2? That means I would go here because 1 mole of hydrogen 2 is over here, and I would need 2 moles of zinc to produce 1 mole of hydrogen 2. Now let's look at number 2 and do the mole ratio for number 2. It would be 2, 2, 3. That's the mole ratio. So you just do the coefficients of each grouping. Now let's look at number 2 and look at a question that might be asked of number 2. How many moles of potassium chloride are in the products? And if we were given that question, we would say 2 moles of potassium chloride are in the products. Now let's go to number 3 and do our mole ratio for number 3. It's going to be 4, 3, and 2. All right, and what if I asked you how many moles of iron 3 oxide were produced in this equation? You would say 2 moles of iron 3 oxide were produced in this equation. Alright, now that we've completed these examples, let's do a couple of examples again, but I'd like you to do them on your own. Alright, give the mole ratio for the following equation. I would like you to pause the video and determine which one is the correct mole ratio. And resume the video once you're ready for the answer. Alright, the correct answer to this is C. The mole ratio is 2, 1, 2. Now let's do one more practice problem. How many moles of magnesium are needed to make 2 moles of magnesium oxide according to the following equation? I would like you to pause the video, determine your answer, and resume the video once you're ready to check it. The answer is A. You can see right here that 2 moles of magnesium oxide is right here in the answer already. And so I need 2 moles of magnesium to make the 2 moles of magnesium oxide. Alright guys, I would like you to go ahead and look at your practice problems number 1, 2, 3, and 4. I want you to go ahead and pause the video and try these questions and resume once you're ready to check your answers. Alright, for question number 1, how many moles of dicarbon heptahydride are in the reactants? The answer would be 2. How many moles of oxygen are in the reactants? The answer would be 7. How many moles of carbon dioxide are in the products? The answer would be 4. And how many moles of water are in the products? The answer would be 6. Let's move to number 2. How many moles of hydrogen does it take to make 2 moles of hydrochloric acid, or HCl? It takes 1 mole. How many moles of chlorine does it take to make 2 moles of HCl? It takes 1 mole. Then let's go to number 3. in this reaction, how many moles of hydrogen are produced? And that's going to be 1 mole of hydrogen because it's the hydrogen on the right side of the equation, or the products. Now, what is the mole ratio for these reactions in number 4? We're going to have 1, 1, and 2. And then for B, we have 2, 7, 4, 6. And those are the mole ratios. Please write down any questions you have if you got these wrong so that we can talk about them in class. Now, let's look at classifying reactions. The first type of a reaction that we have is called a synthesis reaction, and there are 5 total that we're going to talk about. Synthesis is the first reaction we're going to classify, and it is when you combine substances. So if you look, it's when you take A plus B, and it gives us AB. Now, this is an example down here. This is where you've got magnesium, 3 magnesium coming together with nitrogen, and then they make magnesium nitride. Okay, so you see 2 separate elements coming together to form a compound. That would be synthesis. Another everyday thing to think about, I'm sorry for those worm lovers out there, but if we have a skinny, hungry bird and it sees a worm, we've got 2 separate items here. What's going to happen to that worm? It's going to end up in the belly of the bird. So the bird ate the worm, and it became one thing. We've got the bird and the worm and the bird are all together at the end. So that's just one way to remember what a synthesis reaction is. It's when you take 2 separate elements and you put it together to form a compound. Now let's look at decomposition reactions. Decomposition reactions are when you break substances apart. So right here, if you look, we start with a compound, AB. And the decomposition reacts, it splits them in 2 separate elements. So this is just the opposite of synthesis. So look down here. We have CaCO3, that's a compound. And then it breaks apart into calcium oxide and carbon dioxide. And so that's when you take one thing and you break it into 2 or more things. Now let's look at an everyday example. This is when we have a lovey-dovey couple over here. This happens at high school a lot. But then all of a sudden it goes through decomposition, and what happens? A breakup happens. So they're together at the beginning, but they're broken up at the end. Now let's look at combustion. Combustion reactions use oxygen as a reactant, but I need you to add something to your notes here. I need you to add that they also have water as a product. Okay, so that's going to be your trick to know when you've got combustion. You're going to have oxygen as a reactant and water as a product. So make sure you know that. If you only have one of those things, you do not have combustion. So down here, I've showed you what one looks like, okay? And this is where we have O2 on the left-hand side, which is our reactant, and we have H2O, which is on our product side, and so that's water on our products. You have to have them by themselves. This oxygen can't be with another element. So you have to have oxygen all by itself like it is here, and water all by itself like it is here. So oxygen on the left-hand side, water on the right-hand side always means you've got combustion. Now let's look at single displacement reactions. Look at our example right here. We start with a compound AX plus a single element B, and then we're given a compound BX. So the X has moved over and switched partners, and then the A is a single element. So I've shown you down here. If you'll look, we start off with a blue circle and an orange circle together, and then the green circle is by itself. And at the end, the blue circle is by itself, the green and the orange are together. And so that's just showing you that one of the elements switches partners. Now, here is one written out for you in actual chemical reaction or chemical equation form. We have iron plus copper sulfate. And then at the end, it goes through it goes through a single displacement reaction to give us copper by itself and iron sulfate together. And so you just have one thing that is switching partners. So it's kind of like going to a dance where Mr. Red Shirt here in his sunglasses goes to the dance by himself, but these two dressed in white, they've gone to the dance together. They go through a single displacement reaction, and Mr. Red Shirt actually ends up dancing with the lady dressed in white, and the guy dressed in white's by himself. So they've switched dance partners, if you can say it that way. Hopefully that'll help you remember it. Now let's look at double displacement. Double displacement is when you have two compounds and they both switch partners to make two new compounds. Okay? So double displacement, here's an example. We have silver nitrate to begin with plus sodium chloride. And in the end, we have silver chloride with sodium nitrate. All right? And so they just both switched dance partners in this instance. So they both go with dates to the dance, but they end up leaving with the other person's date. Now, this is an example of double displacement. If you'll see here, we've got the guy wearing the tiara and the lady wearing the pilgrim's hat. They go through double displacement and they both switch. Where the guy is now wearing the pilgrim's hat, the lady is wearing the tiara. All right, guys, now what I'd like you to do, you have 5 practice problems, and I would like you to go ahead and do those in your notes. So pause the video while you try to tell which type of reactions those are. And remember, it's just going to be one of the 5 that we've discussed. And then I would like you to resume the video when you're ready to see the answers. Oh. All right, let's go ahead and look at these answers. For number 1, this one is going to be a double displacement. Number 2, when we look at it, it's combustion. Now, combustion sometimes is the hardest one, but just remember, if you have oxygen by itself and water on the product side, then you're going to have combustion. Number 3 is a single displacement. Number 4 is synthesis. And number 5 is decomposition. Okay, go ahead and make sure you jot down any questions you have about mole ratios or classifying reactions so you can ask me in class tomorrow. I hope you have a wonderful evening, and I'll see you in class.